Hello students, welcome to the course CS371 Data Communication and Networks. I am Dr. Munir Omar. Today in KCMS activity number 37, we will be studying about switching. These are the main contents of our today's lecture. First, we will have a general overview about the connectivity among different devices. Then we will define the switching, the role of switches in path establishment. After that, we will discuss the types of switched networks. We have two broad types. The first one is circuit switching, and the second one is packet switching. So, we will also discuss these two types, and inside the packet switching we have further two types. We would also study about those two types in this lecture. Okay, first let's have an overview. So far we have studied about the networks. Networks are used to interconnect many devices. So definitely there would be multiple channels among the different devices or multiple paths, and there would be some sort of options for the path establishments or route establishment. We have studied about the local area network, and now we are starting with the wide area networks. In the beginning, when the telephone systems were invented, that time the circuit switching has been the dominant technology for voice communication. So that time the switching was circuit switching. Later in 1970s, with the evolution of datagram networks or digital communication, packet switching has evolved substantially for digital data communication. The packet switching was designed to provide a more efficient facility than circuit switching for bursty data traffic. The main objective of packet switching was to handle the digital data communication among different devices, where the data is transferred in the form of packets from one device to another device. Long distance transmission between stations, called end devices, is typically done over a network of switching nodes. So, whenever we connect two remote devices, there might be some intermediate devices for connectivity, and these devices can be switching nodes. And we have, for example, we have multiple devices communicating with each other, so there might be some switching nodes in between those devices for switching the traffic from the source to destination nodes. Switching nodes do not concern with the content of data. The main objective of switching nodes is to divert the traffic from one node to another. Their purpose is to provide a switching facility that will move the data from node to node until they reach their destination. So, we might have two devices communicating with each other. So, it is possible that we may have some other devices in between these two devices which divert the traffic from one node to another node and ultimately reach the destination node. So these nodes are referred to be as the switching nodes. So the data is actually routed from one node to another node by using these switching nodes. Here we have a figure showing the switched network. These ABCD, these are the end devices, and in between we have some physical switches installed. Now let's say A is a source node and E is the destination node. A wants to send some data to E or want a connection with node E. So these switches will perform special function for establishing a route between these two nodes. So this one switch has the option to open this one port. Actually, this switch will open this port, and now it has options to open either of these four ports. So it will open this one and connect these two ports. After that, this switch can connect this port with one of these three. So it can connect this one. It can also connect this one for the path establishment. The path establishment depends upon some different algorithms. So let's say it connects these two ports. After that, this one is connecting this one port, and then this last switch connects this port with this one. So in this way, the path is established between A and E. After that, A and E will be able to communicate with each other. Meanwhile, if B wants to communicate with C, so it must wait until this communication overs. Switching. An internet is a switched network in which a switch connects at least two links together. So one switch can connect at least two links together. If you look into this figure, these switches were connecting two links together to establish a path between A and E. A switch needs to forward data from a network to another network when required. This can also be from one device to another device. The two most common types of switched network are circuit switching and packet switched networks. These are the categories of switched networks. We have circuit switched networks. We can also call it circuit switching. Then we have packet switched networks. And third type is message switched networks. The packet switched networks can be further divided into the datagram networks and virtual circuit networks. First, we have circuit switched networks. A circuit switch network consists of a set of switches connected by physical links. These switches are physical switches, and these are connected with some physical links, just like we saw in the previous figures. Here we have some physical switches, and some physical links are connected with these switches. A connection between two stations is a dedicated path made of one or more links. In circuit switching, the path, if established, would be dedicated between the connecting devices, and that path would not be shared by any other device, just like here. If this path is established, then the node B or node J would not be able to use this path because this one is now reserved for node A towards the next switch. So this is a dedicated path and it cannot be shared. However, each connection uses only one dedicated channel on each link. Each link is normally divided into n channels by using FDM or TDM. However, there is one another thing, that is the links. These links can be shared among the devices by using FDM or TDM, we have already studied about frequency division multiplexing and time division multiplexing. So by using FDM or TDM, we can share the links among these devices while having circuit switched network. Circuit switched networks. A circuit switched network is made of a set of switches connected by physical links in which each link is divided into n channels. This figure shows a trivial circuit switch network. Now, if we look into this figure, we have some switches connected to AND devices. Now, this one switch is connected with six AND devices. Among these six AND devices, node A is also a devices. Node A is also a device connected with this switch. Each switch is further connected with a multiplexer. These symbols are showing multiplexers. Now, suppose A wants to communicate with node M. So, for this purpose, what will happen? This switch will take A, multiplex it with some data from or some connections from other switches, and after that forward it to the next switch. Here this would be demultiplexed, and again this switch will forward the connection of A to another multiplexer, and this would be further multiplexed, and through this path it would reach to the last switch after demultiplexing, and ultimately this A will reach to M by having three intermediate switches and multiplexed paths among these switches. The multiplexing technique can be TDM or FDM. So these are physical switches, and these switches are connected with physical links. So once this link is established, then it would be a sort of physical link or dedicated link between A and M. In circuit switching, the resources needed to be reserved during the setup phase. The resources remain dedicated for the entire duration of data transfer until the teardown phase. Let's consider an example for circuit switch network. This is example number 1. Let us use the circuit switch network to connect 8 telephones in a small area. Communication is through 4 kilohertz voice channel, and we assume that each link uses FDM to connect a maximum of 2 voice channels. So the size is 4 kilohertz for a voice channel, and using FDM we can multiplex 2 voice channels. So the bandwidth of each link is then 8 kilohertz, 4 plus 4. Now here in this figure we can see that we are connecting 8 telephone connections, and each of these devices are using 4 kilohertz bandwidth, and in between we have some switches connected with multiplexers, and these multiplexers are actually FDMs, frequency division multiplexer. The technique is frequency division multiplexing, and two channels are multiplexed means that the multiplexers can take two inputs. Now if you look into these multiplexers, each one is taking two inputs, 4 kilohertz plus 4 kilohertz, and the output would be 8 kilohertz. Now If we look into this telephone set number 1, it is connecting with this multiplexer, and here number 3 is also connected with this multiplexer. Both are combined on the path having 8 kilohertz frequency, and then multiplexed data is demultiplexed here, and the path is completed by connecting these two sets with these two. So 1 and 3 are connected with 7 and 8. Telephone 1 is connected to telephone 7, 2 to 5, and 3 to 8, and 4 to 6. So in this figure we can see that all the telephones are first multiplexed and then first switched towards the multiplexers, then multiplexed, then demultiplexed, and then switched towards the destination telephones. Let's have the example number 2 about circuit switching. Here we have a figure. In this figure we have a T1 line having 1.544 Mbps. This is a leased line, and this line is used to connect two offices. In each office there are 4 computers. Now consider a circuit switch network that connects computers in 2 remote offices of a private company. The offices are connected using a T1 line leased from a communication service provider. So 2 offices, office number 1 and office number 2. In between we have a T1 line having 1.544 Mbps, and these 2 offices are now communicating with each other. In each office there are 4 computers. There are 4 into 8, 4 inputs and 8 outputs switches in this network. Now here if we look into this figure, there are 2 switches, this one and this one. These are 4 into 8. So these switches are taking 4 inputs and 8 outputs. So these are outputs. 4 outputs are here and 4 outputs are here. For each switch, 4 output ports are folded into the input port to allow communication between computers in the same office. Now if we look into this figure, these 4 outputs are actually used to allow the systems to communicate inside their offices. So let's say this one wants to communicate with this number 1 wants to communicate with number 2. So what will happen? This is input. It will take this output inside the switch, and this connection is now established. Then the other 4 outputs, 4 other outputs, 4 other output ports allow communication between the 2 offices. Here, these 4 output ports allow these systems to communicate with these systems located in a remote office. So, if number 1 wants to communicate with number 1 in this office, so it would go through this channel, and this would be a dedicated path between number 1 here and number 1 here. Now delay in circuit switch network. The delay in this type of network is minimal. During data transmission, the data are not delayed at each switch. The resources are located for the duration of the connection. In this figure, we can see the idea of delay in a circuit switched network when only two switches are involved between two hosts. Now, if you look into this figure, there is no waiting time at each switch. The total delay is due to the time needed to create the connection. Now, actually, this one is the time, so it has uh, a bit downward slope. So this time is actually due to the establishment of connection, and also this time is taken by the data transfer and also the disconnection of the circuit. The delay caused by the setup is the sum of four parts. So for setup, we have four things. The first one is the propagation time of the source, the propagation time of the source request, then the request signal transfer time, then number three, the propagation time of the acknowledgement from the destination, and the last thing is the signal transfer time of the acknowledgement. The last thing about circuit switching, switching at the physical layer in the traditional telephone network uses the circuit switching approach. So this is performed at the physical layer. Now we are moving towards the datagram networks, which is the second type of switched networks. And that is actually performed at the data link layer, not the physical layer.